remember what domain is, what the range is? Nobody got an extra one of these? Like, doesn't feel like you have one stuck to another? No. So a basic definition for domain. Just basic. What's domain? Yeah, so domain basic, x values of the graph. So a basic definition of domain would be the x values of the graph. But specifically as you're reading it from left to right. So when you're looking at the graph, we're going to be explaining domain starting on the left of the graph, moving to the right of the graph. So we read the x values like we read a book. You start on the left side, you read to the right side of the circle. Same thing with the graph. So what would the range be then? Odette, what's the range? Yeah. In the y values, you read from the bottom to the top. So you start at the lowest value, you go up to the larger value. And then the last one here is a function. Some of the graphs we look at will not always be functions. However, when we start applying this to equations, we're going to deal with rational and radical equations because those are the expressions we've been working with. They all will be functions. So we might not find domain and range of functions just to kind of get you to remember what domain and range are. But if we work with an equation, we're working with a function at this point. You won't learn new equations or problems that are not in function form until you get to precalculus. So everything we do for the rest of the year pretty much is a function, besides trying to find domain and range of basic graphs. So what is a function? If things can be functions and other ones are not. And I said we're learning only functions for the rest of the year. And we still have a whole bunch to learn yet. What is a function? Connor?
Is it a graph that has no input values?
Yeah, exactly. So he said the input values cannot go to multiple output values. So we usually say that each x has exactly one y. Bless you. Bless you. Which is what Connor just said. So the x value can only have one y, so the input can only have one output. graphically, we're going to be looking to see, does it pass the vertical line test? We call that the vertical line test, the VLT. So if something passes the vertical line test, that means you're drawing vertical lines and making sure it only goes through your graph once. If it goes through 2 points on the graph, that's when your one x value would have two y values, and that's not a function. So if you have a picture to look at, the vertical line test makes it really easy to kind of decide what's going on with the function or whether it's, maybe it's not a function. So there are 3 problems here. And then we're going to go over a couple more vocab, and we're going to try and then continue to work on domain and range. But the first one here, we have a set of points that are not connected. Don't connect the dots. They're supposed to just look like this. And it wants us to find the domain, the range, and then just decide if it's a function or not. So Connor said the domain would be the x values, and I said from left to right. So we're going to write the x values in order from left to right. So in this case, you just have the x values that the points touch, because there's no connection going from one value to the next. So the first x value is at -3. We have -2, -1, 0, 1, and 2. And again, there's nothing connecting those points, so it's just those x values, because it's not the x value of -1.5, because there's not a point or a value that's connecting it there. When you just have a set of points, we put those little squiggly things around it to show that that is a set of numbers specifically relating to this graph. Those little squiggly things are called braces. So they actually have a name. They're called braces. So when you look at the range, you're looking at the y values from the bottom to the top of the graph, and you're just listing those y values. And same thing, if they're not connected, they get the little braces around them to show that it is a set together pertaining to the graph we're looking at. So Holly, what y values do you see?
-2, 0, 2.
And then the last question would be, is this graph a function? So does each x have one y? Or you can do the vertical line test and draw vertical lines through those points and make sure that your vertical line only touches one point. So Holly, would you say it's a function or not a function? Yeah, it is a function. So again, do the same thing for the next one. Looking at the domain. Abby, what do you think for the domain? So just listing the x values from left to right that the points are touching. Tatum, how about the range values? And then the last question, is this a function? Matt? Why not? Yeah, so the x value of -1 has two y values to it, so that value makes it not a function. So one set of points there creates the whole graph being not a function. Now the last one is a little different because it's not just a set of points. You now have a curve that's connected. Kind of looks like a parabola that got lazy. So instead of our u going up or down, it kind of just went to take it out and it fell on its side. And we want to try and find the domain. So remember, the domain are the x values, starting from left to right. So go back to like when we talked about this in chapter 2, which was, yes, I know, September. It was a while ago. But how could we write the domain values for this graph? What did it? Yeah, x is greater than or equal to 2, because there's a point here at the x value of 2, and all the numbers are bigger than 2. So because they're bigger than 2, they move on forever, and they get increasingly larger and larger and larger. So we write that as an inequality. X is greater than or equal to 2. Sorry, I wrote that under the function part. Let's move that to the domain part. So then we need to think about the range. The range would be from the bottom to the top. Odette, what do you think of that? Yeah, so she said it's bigger than negative infinity and less than positive infinity. So that was one way that we wrote the range when it touched every single value. The other way we wrote a graph when it hit every single value is also to use that all real numbers symbol. So it stretches down to negative infinity, it stretches all the way up to positive infinity. These little arrows means it's going to continue to go on, and it's just going to continue to stretch and get wider and wider and wider. So the part that I skipped over, is this a function? Maddie, is this one a function? No, not a function. So you can do the vertical line test once, and right away it passes through the graph 2 times. So therefore it's not a function. Questions? So the difference from writing a set of points versus a continuous graph, meaning those points are connected together. So the ones on the left are called discrete because they're separate pieces. This one is continuous because all the points are connected and continue on. So we're going to look at a specific way to write domain and range for continuous graphs. So this applies to continuous graphs, and it's called interval notation. It's the notation that you will use from now on until you're done taking math classes, which probably will be at least your freshman semester of college, your first semester of freshman year. So interval notation describes the domain and range of continuous functions. Without using inequalities. So we're getting away from using the inequality symbols. We're going to be using this new notation. And there are 4 different options for interval notation. And we'll kind of be talking about what each of those mean and how to try and write it in interval notation instead of using inequalities. But there are 2 main differences underneath. And pretty much the difference would be, is there a bracket versus a parenthesis and what that represents. So some of them have brackets and parentheses, others have like a double bracket or a double parenthesis. But if you have a bracket in the problem for interval notation, a bracket is the same thing as saying less than or equal to or greater than or equal to. It means the number is part of the solution. It's included in the solution. So a bracket means it is equal to that number is part of our domain, it's part of the range, it's part of the answer. And we used greater than or equal to, less than or equal to before. So the equal to part, now we're translating into a bracket. So that means the other option would be the set of parentheses, and that's just when it's less than or greater than. It's not equal to it. So that number is a part of the answer. It might get really close to it, but it never becomes the exact value of the answer. So anytime you would say less than or greater than, like we did right here, less than, we would use a parenthesis. So there are 4 options down below, and we're just going to talk about those 4 options. And then we'll see if we can try and start writing domain and range using the interval notation instead of using inequalities. And I actually think it's easier because then you don't have to worry about which way your inequalities flip. And instead, you're just kind of focusing on 2 values and whether it's a bracket or a parenthesis around those 2 values. So the first one, we have a bracket A and B. So A and B are numbers. A is a starting point, B is where you end. So these values have to be in increasing order. Which is why we read a graph from left to right, because you start with your smaller number, you increase to the right. Or we read it from the bottom, you start with the smaller number, we increase to the top. So A and B must be in increasing order. If they aren't, it's wrong. So if you have 8, 7, 8, 7 is not correct. 7, 8 would be increasing order. So this bracket around A and B is the same thing as saying A is less than or equal to X, which is less than or equal to B. That's how we would write it as an inequality. So as an inequality, we even have an extra number or variable in there. We use the X to show that we're writing domain. And the A and the B represent where it starts and where it stops. So if we just go above here to the one that we have this domain, we have an X here, and it says it's greater than 2. So we're taking the X out of the problem, and we're taking the inequality out. But we're going to have to apply 2 numbers to that interval. So going to the right, if they just have parentheses instead of brackets, it's the same exact thing, except that those values aren't part of the answer, so that would just imply that they're less than. So A is less than X or Y, which is less than B. But notice like the inequality symbols are always pointing to the one direction because we're starting with a smaller number working to the bigger number. The other 2 options is when you might have both things happening in the problem. One number might be included, but the other one isn't part of the answer. And so that's why you have a bracket and a parenthesis. So I would write A is less than or equal to because there's a bracket around the A. That means A is part of the answer. But B is not part of the answer. So maybe we had a closed circle at A, but an open circle at B. And that's why we would have both options in the domain or in the range. But again, we're taking out those inequalities, and now we're just focusing on brackets versus parentheses. So then the last one would be the flip. If the parenthesis is around the A, that means A isn't part of the answer, it's not included. But B is. And we'll look at options so that you can see all 4 of these and what they look like in a graph. So we're no longer using inequality symbols. You'll no longer be using X or Y. Instead, you'll just say the domain is this, the range is this, and you'll be using brackets or parentheses. So I believe the example below asks you to go back above. So it says, write the domain and the range from examples above using interval notation. So we're going to go back to those examples above. And for number 1, I'm going to tweak this just to make it a little more interesting. I now want you to connect those points. I can put another one here to make it more symmetrical. And we're going to write the domain and range now using interval notation, except now our points are connected for number 1. And I always just use a D and an R. You have to state what you're finding. So you have to say this represents domain, this represents range, because we're no longer using X and Y. So for the domain, since this is now connected, we're not looking at this domain, we're going to look at the connected points. From left to right, what's the number that it starts at on the left? Where does it go to on the right? Those are the 2 numbers that go inside the interval. So where does it start on the left? Where does it go to on the right? Julia? Right. So because I connected them, this is going to stretch forever to negative infinity. It's going to stretch forever to positive infinity. So those are the two numbers that go in our brackets or our parentheses. Now, Julia, do we actually know what negative infinity and positive infinity are? No. So because we don't know that exact value, they will always get parentheses around them. Anytime you use an infinity symbol, you're going to have parentheses around that value. So the domain would be negative infinity to positive infinity, parentheses, because we don't know that exact number. And then that's it. So I don't need to worry about inequalities. We don't have to worry about x. It just starts at negative infinity. It goes to positive infinity. So looking at the range is tricky because you have to start at the bottom of the graph and work your way to the top. So what's the lowest number that it goes to? What's the highest number that it stops at? So Mackenzie Myers, what's the lowest number that the graph of number 1 goes to? Yeah, it's also going to negative infinity because it's going down forever. And then how high does it go, Mackenzie? 4. Okay, so then you have to decide what to go around those. So what goes around the negative infinity? A parenthesis. And what do you think about the 4? Why a bracket? Yeah, it's a point of the graph. So here's a case where you have a parenthesis around the left and a bracket around the right. So parenthesis always around infinity. That 4 is a point, so it's included in the graph. You cannot write domain and range for points that are not connected. So in number 2, we can't write it as an interval because those points aren't connected together. So that one cannot be written in interval notation. But number 3, those points are connected together. So do the same exact thing. What's the first number that it starts at on the left? Where does it go to on the right? And those are the two numbers that you're writing down. So Garrett, where does it start on the left?
2.
At 2. And where does it go to on the right? And then what goes around those?
Bracket on the left.
Perfect. So now we have a bracket on the left side because there's a point right here. That's a point. It gets a bracket. Parenthesis because it's infinity and we don't know that value. And then the range we said was negative infinity to positive infinity as an inequality. So it's also negative infinity to positive infinity as an interval. Parentheses because they're both infinity values. Let's see. So when you flip the page, you'll see, I believe, 6 graphs, maybe 9. 6, looks like 6. They get increasingly more difficult as you kind of work down through them. So our goal is to just see if we can decide if it's a function, list the domain and range as intervals now. So now it's interval notation left to right. First question, is it a function? Does it pass the vertical line test? Does each x have one y? So Jewel, what do you think? Is this one a function? Yeah, it is a function. And then moving from left to right, what is the domain? So where does it start? Where does it go to? Will, what do you think? Where does the domain start? At negative 8, and then it goes all the way to? And what goes around negative 8 and 5? Perfect. And that's it. So you don't have to worry about writing an x. You don't have to worry about flipping your inequality symbols or how they go. It starts at a point at negative 8. It continues all the way through. The last point it stops at is 5. And then looking at the range, at one point, looks like it's a little off my graph when I was drawing it. That is the highest point of the graph, the point that's drawn or plotted on there. My little guy didn't connect very nicely there. So Rebecca, what would the lowest point of the graph be? And the highest point of the graph? And what would go around there? Brackets. So you're finding the minimum, you're finding the maximum, and writing those points. So Eden, number 2, is this one a function? Yes, it is a function. Domain of the range will be how far it stretches left and right. Eden, how far does it stretch left and right? Perfect. What goes around those two symbols? Excellent. And then the range, the lowest to the highest point. Perfect. See if you can do the next two pairs right underneath. I think number 5 is probably the most interesting of the graphs, 5 and 6. Let's see if you can get the next two pairs that are underneath here. Next two graphs. Maggie, is number 3 a function? Why not? Yes. Okay. Yes, it is a function. What do you think the domain is? -5 to infinity. And then the last question, what goes around those? Perfect. Why does the -5 get a parenthesis? Excellent. So this is an open circle right here. So therefore it's a parenthesis. How about the range? And they also both get good. So Melanie, the next one, what is this one a function? No. What's the domain for this one? So what's this left value right here? There you go, -1, and then all the way to the right. Parentheses or brackets? Yeah. Unless there's an open circle there, it's part of the graph because it has a continuous line that's going around that. That graph is called an ellipse. So that shape is an ellipse. And then the range going from the bottom to the top. Mackenzie Mallory, what do you have for the range? And what goes around those? Perfect. Any questions with those two graphs? So I said 5 looked to be probably the most interesting, but 6 is pretty interesting as well. So 5, we have 3 separate lines. We talked about this in chapter 2 being a piecewise function. So you have multiple functions, but only pieces of them combined together, they make one graph. So is this a function? I just said it was called a piecewise function, but is it a function? Does it pass the vertical line test? It does. So if you look at the point, there is a closed circle versus an open circle. So that means the point exists, the one below it doesn't. But that makes it a function because one is closed and one is open. And that same thing happens on the other side. So this point does exist, even though that one happens to not exist. That means it is a function. If they were both closed, then it would not be a function. So this is a function. So now remember, the domain is all of the points from left to right. So looking from left to right, what is the domain of this graph? So think about the x values as you move from left to right. We need to make sure what's happening with all of those x values. take a shot at it? Debt, maybe? It is negative infinity to positive infinity. Because if you're looking at x, this is going to negative infinity. Yes, it stops here, but then it picks right back up right after it and continues on with this horizontal line. So that horizontal line is touching the very next little point that's right after that. And same thing then, it goes back up here and it continues on. So it's from negative infinity to positive infinity. The range is a little different as well. So you're looking from the bottom to the top. And maybe you just want to look at this top part of the graph for now, because this top part of the graph is doing the same thing where the bottom horizontal line is doing something totally different. So just kind of looking at the top part of the graph, Abby, could you give me a range for the top two diagonal lines? So it goes to positive infinity. What's the first point that these are touching for the y value? 0. Yeah, they're touching 0. My board up some. So these are touching 0, so that part of the top part of the graph starts at 0. This one has a point at 0, that one doesn't. But once you have a point at 0, that point exists. So we would put a bracket with 0 and a parenthesis around the infinity. However, there's another y value that exists in this graph. Abby, what's the other y value that the graph is touching? -3. And it's only touching -3 because it's a horizontal line. So we would have another part to this domain, and we're going to put it in braces because it's just the number -3 by itself. That -3 doesn't go anywhere because it's just -3. Always -3 for that line. So the -3 is separate because it's not vertically connected to anything. And then the other part would be from 0 to infinity. That's for the two diagonal lines at the top. Questions? That one's a little trickier. Okay, so looking at the last graph here, Connor, is this one a function?
No,
Why not?
because it's a circle.
Yeah, the circle. So one part is a circle, together they make the whole graph. So I can't say one part on the right is, or left is a circle, the part on the right isn't. Both together make the entire graph, so this is not a function. So Connor, do you think you could describe the domain from left to right?
There are 2 parts.
There are 2 parts, so we have to describe the domain of the circle, we have to describe the domain of the line. So Connor, what's the domain of the circle?
-8 to 1 negative.
And what goes around those -8 and -1 values?
Brackets.
Good. And then how about the domain of the diagonal line?
2 say positive infinity.
And what goes around those?
Parentheses.
Perfect. Good. Those are parentheses. So 2 separate pieces that have different domains. So we describe them using different pieces. All right, so then looking at the range, remember the range is the lowest point to the above point. And the range, there's kind of like overlap. So we don't need to have 2 separate ranges because it starts here, and then yes, the circle stops, but the line keeps going. So there's like overlap, and we don't need to include that overlap in the range. So going from the bottom, looking at both graphs, moving to the top, Tatum, where does the circle start at? What's the lowest point of the circle? -2. And then the line goes to positive infinity. So the -2 is a bracket, but the positive infinity gets a parenthesis. And that's because there's this piece that's like overlapping right here, but it just continues on. Even though they're separate, that range value is continuing on. Questions? So if you flip the page, there's just a little bit of review on that next page, kind of getting you to remember things about functions and evaluating functions. Again, this was chapter 2, so this is kind of good to review, start to get back in your memory bank to think about, especially for that midterm exam. But we're going to be looking at functions similar to these, and we're going to start trying to combine them together. So just reviewing here, if it says evaluate the following functions, what does it mean if it says f of 2? What are you supposed to do to evaluate? I know it was a while ago. Melanie, do you think you remember?
No, you put 2 in for x.
Yeah, the number in parentheses represents x, because usually we read this as f of x. The letter outside tells you which equation to use. So we're using the function f. We're plugging in a 2 for x. So we would have 4 times 2 minus 10. So Melanie, 4 times 2 is? Minus 10 gives us? Negative 2. So this piece here is notation. And that's where it's weird, because you want to try and do something. Usually we're trying to get a variable by itself, but they go together. So this tells me from the function f, we plugged in a 2, we got out a negative 2. This is domain, this is range. Input, output. So you don't do anything with the function notation. So the next one says g of 2. So that means now we're going to the g function and we're plugging in a 2. And then you're evaluating. Don't forget, PEMDAS says you do the exponent first. Don't multiply those two together. 2 squared is 4. 2 times 4 makes 8. 8 minus 7 is 1. So g of 2 is equal to 1. So I'd like you to finish those evaluating problems. And then I have a worksheet that is just on looking at graphs and trying to write the domain and the range. So obviously the work part is minimal. As you're writing domain and range, you're not really algebraically plugging things in for the equation. So there are 12 graphs and then 2 little word problems. And then I'd like you to finish up those evaluating problems. And I have 9 on the back and 13, if anybody would like to do 9 or 13. Maddie and Matt? Maddie 13, or 9, Matt 13?